Siddharth, I'll come to you. Let me give a chance to Shweta Tejaswini. Have you understood the question, Shweta? M. Shweta Tejaswini, did you understand the question? Or should I repeat the question? Hello? Shweta, is the question clear? I think Shweta is not able to hear me. Okay, Siddharth, you're trying. Siddharth, you're trying something. Hello? Hello? I thought as 44 is there, in level 2, we won't be taking 50 again, sir. No, not, that is not the logic. That is not the logic. Okay, somebody else, so Jai Shankar. Shweta, why are you not answering? Have you not understood the question? Shweta Tejaswini, M. Shweta Tejaswini, why are you not answering? You should take the question. Doesn't matter if you answer it right or wrong, that's a different issue. Okay, Jai Shankar. Raghavendra, I'll come to you. Let me see what Jai Shankar has to say. Raghavendra, please wait. Raghavendra Pramanjan, please wait. Okay. We are skipping 50 as we come to express lane. Okay, I do not know whether you guys are understanding the question. See, somebody is there, Sri Soumya. If all nodes on the normal lane be there in express lane, then there will be no use of. Agree. There is no doubt about what you have stated, but that is not what I was trying to hint at, Soumya. Soumya, that is not what I was trying to hint at. Okay, let me take some other example which is there, maybe. Okay, let's see this. I have 10 here. Yeah, in the 10 is there in the express lane, and 30 is there in the express lane. Okay, now suppose 22, I want to take it to level 2. 22, yeah, Raghavendra, you are saying every express lane should have n by 2 nodes. That's a good answer, Raghavendra. That's a good answer. I'll come to your answer a little later, but let me go to much more basic, because that basic has to be absolutely clear. My question to all of you, level 1, I have 10 and 30. In level 2, I would like to add 22. Can I add? You can't go back to normal lane. Aman Singh says yes, and Suprit Gaud says no. Okay, others please wait. Let me talk Aman Singh. Aman Singh, my question to you is that level 1, I have 10 and 30 in the express lane. In level 2, can I add 22? You are saying yes. And Suprit Gaud, why are you saying no? Yes, Suprit Gaud, go ahead. Suprit Gaud, please. Others, please wait. Sai Surya, please wait. Suprit Gaud, why are you saying no? Or adding 22 in lane 2, in level 2. In the express level 2, we want to add 22 but express level 1 doesn't have 22. Can we add? You are saying no. Can you justify why you are saying no? See, if you understand the algorithm, then you will be able to do the corresponding code. But if you are not understanding the algorithm, some answers are, if every node is there in the express lane, then what the use? Yes, that is not the aim. That is not the aim. The question is not directed toward that. Suprit God, hello, are you trying? Why are you saying no? Okay, somebody, Suprit, are you trying or no? Raghavendra, you have given that n by 2. I'll come to that little later. Uh, that's one of the good answers, but uh, much basic to that I wanted to ask the students. Yes, Suprit, say something. Okay, somebody else. Yeah, Suprit is here. In express node, we specify down. Yes. So if we take the node which have LL1 to LL2, will be much more better. Express node we specify down. So if we take the node which have LL1 to LL2 will be much more better. Yes, I agree with you, God. Yes, Suprit, I agree with you. That is actually the logic. Aman, that is actually the logic. Because if you go back to that, say, structure of your express node, the structure of express node, the structure of express node. Now, point number one, students, all of you. Point number one, when I was showing you this particular diagram, when I showing you this particular diagram, you can have all the nodes which are there in express lane 1, all the nodes which are there in express lane 1 compulsorily have to be there in express lane normal lane. All the nodes which are there, for example 12, 17, 25, all these are there in the express lane 1. Compulsorily they have to be there in the normal node. Now let me go one level up. All the elements which are there in express level 2 have to be there in express level 1. Are you getting my point? Like 17, 25, 31 and 55 are there in the express lane 2. 17, 25, 31, 55 are qualified to be in express level 2 because they are also there in express level 1. Okay, okay, Mahesh, don't try all this. Fine, if it's by mistake, Mahesh, okay, but fine. No issues, but other students don't try this. Okay, fine. So the basic point is that something which is not there in the lower lane cannot be there in the higher lane. As simple as that. Aman Singh, are you with me? Are you not with me? Right. So if I want to add 39 in express level 2, 39 does not qualify to be a part of express level 2 because 39 is not part of express level 1. Okay, as Suprit has very correctly said, that because the down pointer, through the down pointer only you are coming down to the lower express level, and through express level 1 you are coming down to actually the normal lane. In the normal lane only you have values, right? So are we students, are we clear about this understanding of the skip list? These are the basics of skip list. If we know that, see, what is a skip list? It's a data structure, and every data structure has got properties. isn't it? For example, uh, queues, queues data structure. Queues data structure is what you can insert at the beginning. Sorry, you can exit from the beginning, but you have to insert at the end. Whereas in stacks, you push at the end and you pop from the end, isn't it? So that is the data structure. So also the skip data structure. The skip data structure is such that the le higher levels elements compulsorily have to be there in the lower levels. Okay, so that is the basic premise. In case anybody has got not understood, come to the chat window and ask for the clarification. Otherwise, we are going further. Now, okay, yes, Satyasai, shoot your question. Sanjana, every next express lane should contain the values. Those are in the previous lane, right, sir? Yes. Not. I'll say keys. Sanjana, probably what you are meaning that it is the same, but I will preferably use the word key rather than value, because value is corresponding to every key there is a value. So I'll read it like this. Your statement, I'll read it like this. Every next express lane should contain the key. Those are in the previous lane. You're right. But now, but how do we make the decision that this particular node should be taken into the next express lane? That's a good question. That's a good question. And actually, once I finished all the this skip list code, actually I was going to attempt to that, Sanjana. So please keep this fresh in your mind. And that's a very valid question. But in previous class, I made a very passing reference to your question. The passing reference was like this. One is a toss logic, toss the coin logic, right? When Virat Kohli and the other captain, they go for the toss before the cricket match, whether it's a 1 day or the 5 day test match or whatever. The toss a coin, right? The probability of Virat saying head and Virat winning the head is how much? 50-50. Is how much? 50-50, right? So what one logic says that every time you add a normal node, you just give a query to the random number, and through some random logic, if the random number turns out to be even, then add a node. If random number comes out to be odd, don't add a random number. That is one logic, Sanjana. The other logic is like this. The other logic is you ask the user. You ask the user, do you want to add a express node for this particular node? If the user says yes, then you add. Then you add, right? And some guideline for the user to say that which node should also be in the express node, right? That's some guideline. Somebody, I think I'm just now forgetting the name. Somebody said n by 2, something like that. Somebody, I don't know, one student said n by 2. I missed his name. Whosoever, that is one logic. Who is that? Raghavendra. Raghavendra, is it you? Yeah. So Raghavendra said, suppose there are say 10 nodes in the normal lane, so there should be 5 in the express lane and 2 in the level 2 and 1 in the level 3, right? Probably he is trying to hint at that. But more than that, other than this, there is one square root logic. Square root logic means what? Suppose there are 16 nodes in the normal lane. So square root of 16 is 4. So there should be 4 in your level 1. Square root of 4 is 2. So 2 should be there in your level 2 and 1 should be there in level 1, right? So there is a reason. It is not just an algorithm. There is a reason. So Sanjana has put up a very quite a good question to the entire class, that what is that criteria which will decide that let's have one express node for this normal node. So Sanjana, there are three logics: toss a coin, ask the user, or go by under root logic. Go by under root logic, right? So students, the very first thing, we have defined the structure of the express node, we have defined the structure of the normal node, we have seen the creation of a node, isolated node, we have seen the creation of an isolated express node. Now when we actually start the execution of our express skip list, when we start execution of our skip list, we should have some initialization, right? Initialization of the nodes. What should be this initialization of the nodes? Going to the previous slide again, the leftmost is taken as some minus negative infinity and the rightmost is taken as positive infinity. Means what? We do not have a single node in our skip list, so but we are just preparing ourselves for the skip list. We are preparing ourselves for the skip list. That is what is initialization. So the moment I get into the main means what? The C program's main. I'm calling init function and initializing my skip list. And in this initialization process, as you are seeing it on the diagram, I will not be having any of these nodes. I'll not be having any of these nodes. I'll only cater for minus 9999 in level 1 and normal lane. And I will cater for plus 9999 in the express node 1 and normal lane. Express lane 1 and normal lane. So my initialization list will be minus 9999 and minus 9999 with value minus 9999. On the rightmost, plus 9999 and is a key. The same key is here and corresponding to this plus 9999, the value is plus 9999. Is this premise clear? Students, are you understanding the algorithm? Once you understand the algorithm, then you will understand the code. Once again, some students are, I think you can fire a question, but once again I will explain. The initialization process is minus 9999 in express lane 1, minus 9999 as a key in normal lane, and in the normal lane the value is minus 9999. On the rightmost extreme, plus 9999 is the express node last node, and corresponding to that the key in the normal node is again plus 9999, and the value corresponding to key 9999 is also 9999. So it's going to look like this: minus 9999 and straight away plus 9999, minus 9999 key and minus 9999 value, minus 9999 key and minus plus 9999 key and plus 9999 value. This is the what we are going to do. Okay, with that background, I am calling the init function, and I'm calling the I'm just for the sake of that initialization, first last node and first last express node. I'm just giving a prompt on the screen which gives you an indication that this init function has got called by the main function, and the first statement is I'm giving a prompt that I'm initializing the first and the last node and the first and last express node. Students, are you listening to me? Have you gone to sleep? You understand the difference between node and express node? Express node is the node in the express lane, node is the node in the normal lane. Okay, so for normal lane I'm using cur as a temporary pointer, and for express lane I'll use an express cur as a temporary pointer. Right, so let's begin with the cur. Cur is a normal lane pointer, right? So that cur, this cur, so when I finish this particular line, I in this pointer, the base address of this memory block is created and the base address is stored in cur. What am I doing next? Cur of key. This cur of key, I am initializing it with min. And what is min? Already I have given the min value as minus double nine. So that comes over here. Then next statement, cur of value. Cur of value, I am initializing that with minus double nine. Right? And presently cur of next is null. Presently cur of next is null. Okay. So I am preparing an isolated node which I am further planning to make it as the leftmost node. So this statement is this statement is this, and this statement is presently null. Right? Then I am printing, for the sake of demonstration, I am printing the key of the first and the value of the first is this. Key of the first and value of the first is this. Clear? Now, yeah, this null is also initialized to null. Now next statement. First is equal to cur. What is first? First is the leftmost node. So at the present, the first is going to store the cur value. The first is going to store the cur value. So at the present, two pointers, first and cur, are having the same base address. First and cur are both having the same base address. Now I am going to prepare for the last node, that is the rightmost node. Okay, so again I am reinitializing cur is equal to node, so that whatever is the address that is forgotten and that has gone into the first. Now cur is equal to, I prepare one more cur. Now this cur is not there, so I prepare one more cur, and that cur is going to become the maximum, that is a 9999. Value is maximum 9999. Now cur of next is equal to null. Same thing, that cur of next is equal to null. Okay, so clear about up to this. Now I say last is equal to cur. The last pointer is pointing, so presently the first pointer is pointing to the first node, that is the left extreme node, which is 9999, and the last pointer is pointing to the last node, which is plus 9999. Now this particular node has to get connected to the last node, right? So what we are doing, first of next. What is this first? First of next, presently it is null. That I would like to replace with last. Okay, so when I execute this particular statement, this next is going to point to the base of my last node, right? So this pointer is pointing to the base of my last node. Then I am printing node last key, last of value, last of key, last of value. Clear so far, students? Please open your editor, start typing it. At the same time, any student who has not understood any of the statements, most welcome to use the chat window. The doubt is to clarify your doubt, and same doubt may be lingering in others' mind, but they are afraid of expressing, like how I appreciate Sanjana, who made a very good statement, and probably a lot of students are having the same doubt and got clarified. So please be open, communicative, interact with me. Is this complete code clearly understood? I hope all of you are also typing it out in your editor, because all this create node, create express node, hash define struct node, hash define express node, all the pointers, slowly and gradually we are building our application. Uh, yes, Raghavendra. I am using it to free whatever area it was allocated previously and create one more node. You are referring to this particular statement, right? Yeah. Uh, because we are allocated this, we are saving it over here. Then we create one more in the heap, one more memory location, and in that memory location we are storing different values that we are going to store in last. That's the reason why we are freeing cur. Once we finish the second part of this init function, I'm going to the next slide. I'm going to the next slide. Okay, right. After the last statement, after the last statement, one more statement which is last of next is equal to null. Last of next is equal to null. Are you with me, guys? Why should that last of next should be null? Students, anybody? Why should that last of next should be null? This should happen, isn't it? This thing should happen for that reason. Right. So that's the last note. Okay. Now, if you have gone through this, if you are just instead of cur, now the express cur has come. Instead of cur, the express cur has come. So in the initialization process, it is necessary to create the normal node and then go for the express node. Why? Because in the express node, there is one more pointer nxt, which is pointing to the normal node base address. It's pointing to the normal node base address, right? So I'm taking this express node cur and I'm creating one block. That block, there are 1, 2, 3, 4, 5 elements. That block has got 1, 2, 3, 4, 5 elements. So all the 5 elements we have to populate. All the 5 elements we have to populate. And we are considering that this is express level 1. Express level 1. So if when you execute this statement, express cur key is equal to min, right? That is my minus 999. Express cur express next, presently null. Presently null. Express first is equal to express cur. So what I do? 1 minute. Yeah, express first. We have got it over here, right? So both the pointers are pointing to the base address. For some time, neglect this. Now, I'm just printing what we are doing. Then express cur, right? Express cur, express node, malloc like this, and express cur of key is equal to max. Now we are done with the top one. We are done with the top one. Now let's prepare for the bottom one. Sorry, the right extreme. The right extreme is here. Express cur of key is equal to max. Max what? 9999. Express cur of express next. Now this express next, we are making it as null because it's the right extreme. The express last is equal to express cur. So we are putting this express last and express cur both are pointing at the same location. Right. Then express first of express next. Express first of express next should be pointing to the last node. Right. That last node is there in your express cur. Express first of express next is equal to express last. So this base address we are saving it over here. Next statement. Express last of next nxt is equal to last. Are you getting my point? because it should be looking down. This particular pointer I'm populating. Express last of NXT. Express last of NXT should be looking down, and it should have the last node. Last node, we are in the previous slide, we had already prepared this. We had already prepared this. So that base address is there. So that completes that. And then express last of key. So are you able to understand each and every part of this? Or should I clarify regarding any of the statements? Any of the statements which are not understood? Sir, once you can explain the NXT part. Okay, fine. Rohan, I'll do that. Second part, the Akashdeep, right from top. Okay, I'll take on Akashdeep's this thing. No issues. Last node. Yeah. So then it will answer Rohan's question. So why express last of down is null? Yes. Okay. I'll come to Durga Prasad also. Right. I'll explain everything. Good. See, now we are preparing. We are creating one express curve. We are preparing one express curve because level 1 we are aiming at. Now we know this. So express curve key min is what? Minus 9999. So that's my key. We should not have values because values are there in the normal node, right? So please do not have that doubt. Now what is happening? Express first is equal to express curve. So I am creating one more pointer, and that pointer is pointing to the same base address. Express first of level is equal to level plus plus. In the global, level is taken as 0, so I am making it as 1. Therefore this level becomes 1. This level becomes 1. Express first of next is equal to first. Express first of next is equal to first. What is this next? Next is looking down to the normal node. That normal node is here first. In the previous slide, we have already done first and the last, right? There's a difference between this first and express first. Students, this first is different than the express first. So in the previous slide, we have already created first. So this next should look down to the normal lane. And what is the normal lane? Key is equal to minus number line, and value is minus 9999. Why express last of down is null? Why it must not point to last? Okay. Durga Prakash and other who had asked this doubt. See, what is the data type of down? Down is a pointer. A down pointer, the data type of the down pointer, students, if you remember the structure of the express node, the data type of this down is express curve. The data type of down is express curve. So this down will come from level 2 onwards. This down will come from level 2 onwards. Durga Prakash, have I answered your question? And somebody else has asked me why down is null. Durga Prakash and Rohan, I think somebody missed it. You are asking me this down should be, why not it is last? The data type of down pointer is struct express node type. I won't say general node, I'll say NXT is for normal node. Throughout the class, I'll use that terminology so that there is no confusion. This NXT is to point to the normal node lane. Durga Prakash, where are you? Yes, sir, got it. Okay, Rohan. Sir, from the next level, NXT is equal to null. Absolutely right. Absolutely right, Rohan. From the level 2 onwards, like in level 1, the down is null. In level 2, NXT will be null. NXT will be null. You are right. Somebody else, Durga Prakash, sir, we don't have a pointer called value in express node. So how can we use it in the print statement? Jai Shankar. Yes, Jai Shankar. When I'm coming to that statement, I'll answer your query. Right. So up to here, the point is clear. The express first of next is equal to first. So this is the express first. It has not popped out. It will pop out little bit later. So express first of NXT is equal to first. Then what are we printing? Express first key, express first value. Now Jai Shankar, I'm coming to your question. Yes, Jai Shankar, you got me absolutely right. There's a mistake in this code. There's one. I'm just correcting that error. Thank you, Jai Shankar, for your query. So I'll slightly correct this. Slightly correct this. Express first key is express first of key. Express first of NXT of value. Yeah. 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 Jai Shankar. You asked me that doubt. In this printf statement, if we want to get the value of express current value, then the express current value will be express first of NXT. Through this NXT, we come over here, and from here we go to the value. That is the value. Let me first clear the good clarification which Jai Shankar asked. Jai Shankar. Right. Okay. So we are done with the printing of this. Then we reinitialize this express cur because we have to prepare for the second node. So express cur is equal to this. Now, yeah, express first has come here. Now express cur of key is equal to max. What is this max? This max is 9999. Next statement, express cur of express null. Express cur of express null is null. Reason being, this is the last node, so it's going to point to null. Next statement, express last is equal to express cur. So this express cur and one more pointer is going to be express last. One more pointer is going to be express last. Then express first of express next is equal to express last. What is express first? This is express first, right? Of express next, right? That has to be pointing to the last node. So that is what is happening here. That's what is happening here. Express first of express next is equal to express last, right? This is also express last. Then express last of next is equal to last. express last of nxt is equal to last. Yes. Now when I print, the same correction has to be done as Jay Shankar has pointed out. Instead of saying express last of value, let me do the same correction here also. I have to say of nxt of value. nxt of value. But if level is equal to 2, then it won't work. See, Rohan, this initialization, the initialization which is going to happen is we are initializing only up to level 1. We are going to initialize only up to level 1. If we have to initialize to level 2, then we have to write a code which is going to add the left extreme and the right extreme also. Rohan, I'll come to Bhavana and others. Just a minute. Let me finish with Rohan. Right. Now coming to Bhavana, sir, express first of next of value is nothing but first value. Absolutely right. Bhavana, we are not repeating value because by mistake in the express note, if you have an element called as value, the very basic concept, very basic concept is what? Dictionary. What is dictionary? Corresponding to a key. Firstly, the keys are unique. So, since the keys are unique, for every unique key, there is a value. Right? Now, as I think Bhavana has said, so let me just elaborate. For example, you have a key called 999999. Right? In the normal lane, suppose you initialize to 9999. Right? If I have a value element over here, right, and if I initialize that to 8888, right, so one key is pointing to two values, which is absolutely violating the dictionary norms. Which is absolutely violating the dictionary norms. And through this next pointer, we are coming to the normal node, and then only we are picking up the value here. So since Bhavana had brought this point, good, that I think others also got it clarified. That finishes with the initialization. I hope all of you have typed out so. Any other clarification? Please seek it. Otherwise, I'll go to the next function. Otherwise, I'm going to the next function. Any other? Rohan, wait for 1 minute. Okay, fine. Let me know, Rohan, once you finish. Sanjana, aren't we supposed to increase the level at the end? Level plus plus, you mean? Yes. Yes, we should. Yes, I agree with you with this. Sanjana, I agree with you. We have to increase the level to level plus plus. Okay. So if you are done, actually all of you, I have not shown you the main, but just for the sake of demonstration, I'm coming out of the PPT and I will show you the code which is there on my this thing, on my editor. So give me a minute. Let me open my code. This is the same code, students, which is there on my tesserator. So our minimum value is this. Our maximum value is 9999. Level has got initialized to 0. Then I'm putting some more variables, count, flag, key found, which I'm using it in the further logic. Then first structure is your express node. You also already seen the same structure is here. Then structure of your node, that is the normal lane, which is over here, and these are the pointers, right? The third statement at 480, I'm calling the init function to initialize the left and the right node. So let me first, it is saved. Let me compile it. Yeah. Let me compile it. It's compiled and let me run it. So please see the screen. In main, this is the print statement, initialization, and I'm printing node first key is 9999, first value is minus 9999. Node last key, node is what? The normal node. The key value is plus 9999 and the last value is 9999. Now coming to the express nodes. Express node key is this, and express node value, though you are getting it over here minus 9999, but you are getting it because through the NXT pointer you are going to the first. It is not a part of your express node. Again, express last, the key value is plus 9999, and this value which you are getting is actually this node value, right? There is no value element in your express node. What you are getting it is from here. Okay. Okay. So this is what is going to display all the nodes. I'll select the choice as 6, right? When you select the choice as 6, the normal lane nodes are minus 9999. The value is this. Normal lane last value is 9999 and this. Now displaying the express lane nodes, express nodes. 9999, but this is coming from here. 9999, the value is coming from here. Okay, so when I put the choice as 9, I'm exiting and we exit the code, right? So what I'm giving you the code is actually the executable code, and as Sanjana had pointed it out, let me add that line, level plus plus. This node is 10, right? This is the second node in the express node. The value corresponding to this is maybe say 1111. The keys are this. What I'm showing are the keys. This is the key. This is the key. 10 is the key. This is the key. In the previous slide, we already did a post increment. I'll check back, Rohan. I'll check back. Right? If you are observing, let me check back. But because the code is working, let me check back. But I'm noting your observation that we have already incremented it. Right. Let me finish with this explanation. So display. Now the cur is standing to first. This is my first. So this cur is initially standing to the very first node. This is a node, normal lane, right? First I am displaying the normal lane, then I'll display the express lane. So this statement, cur is equal to first. This cur is also pointing at this. While cur not equal to null. Now cur is having the base address of this 9999. Right? Now then I'll display this 9999. Then cur is equal to cur of next. Now cur next has come here, not equal to null. So it's going to display, assume that this is 1111. Cur of next, 2222. Cur of next, 3333. 4444, like that. And it has come to 30. This 30 has come over here, right? Not null. 9999. Again it goes up. Cur is equal to cur of next. What is cur of next? Cur of next is null. Null not equal to null. False. So you come out of the while loop. You come out of the while loop. Are you clear about the first while loop? Anybody having a doubt in the first while loop? Any doubt in the first while loop? First while loop is showing the normal lane nodes. First while loop is going to show the normal lane nodes, values and the key both. It is not like that, Akashdeep. Therefore, I mentioned these are the what are being shown are only the keys, right? Key of 10. This is a key of 10 corresponding to 10. Assume that the value is 1111. right? Corresponding to key 20, assume that the value is 2222, 22 3333, 23 4444, 27 5555, 30 6666, and then 9999. Key and values are not same. For the sake of simplicity, only the leftmost node and the rightmost node I have taken keys and values as same, because it is taken as left infinity and right infinity. But Akashdeep, keys and values, it may be same, but not necessarily it should be same. You cannot overrule that possibility that key and value are exactly same. You can't overrule, but that is not the criteria. Key and values should be same is not the criteria. Akashdeep and others. So Akashdeep is saying, okay, sir, but I hope others are also understanding. Now, right. Now, let me talk about the second while loop. Let me talk about the second while loop. The second while loop, express cur is equal to first. So this express cur is going to stand at the very first pointer, right? So it is pointing to the base address of 9999. I am printing the value, printing the key and the value. So what the express cur going to print? Anybody? Any one of you? The keys and values corresponding to express lane level 1. Please print out the keys and the values of express lane level 1. Rohan minus 9999. No, nobody has got it right. All the values I want. Surya Teja 10 10 30 30. No, somebody else can try. Okay, Rohan minus 9999. Okay, I'll take Rohan's this thing. Minus 9999 first leftmost. All of you, please stop. Otherwise, this will go off the screen. Others, please stop. Others, please stop. What Rohan has typed, let me deal with him. Minus 9999. Express lane key. Through this pointer, it will come down and pick up minus 9999 as Rohan has very. But Rohan, you should type it as minus 9999 here. Rohan, are you getting my point? Yeah, you are corrected somewhere here. Yeah, minus 9999. Then this is going the while loop. It is going to come to the next node, right? As Rohan has put it as 10. Through this 10, there is a pointer going down, and through this 10, he has picked up some value called as 1111. I'm happy, Rohan, you have taken some different value. Now, through the while loop, express cur is equal to express cur of next. So this next is going to come to 30. Come to 30. And through this 30 is going to come down, and through this 30, Rohan has assumed it as 3333, right? Then next, it comes to the last node, right extreme node, which has correctly said 9999, and through this pointer, it's going to come to the normal laid last node and print this particular value, right? And then express cur becomes null. Null not equal to null is false, and you come out of the loop. Very good, Ron. I'm happy that you got it absolutely right. Students, have you understood the code? Okay. Now what I will do, I'm stopping here. Yeah, yeah, Rohan. I'll just check back. Uh, Actually, yes, what Jaishankar is saying is right. It should have been express curve of NXT of value. Express curve of NXT of value. Okay, so I'm handing it over to Shankar sir and Rohan in the next class. I'll see if it's already there. Then we'll do the correction in the slide. Right.